All right, good morning, guys. Today is Friday. It's Friday, Friday, Friday. Ooh, it's all right. We're doing lesson 24 today. Uh, please note the pages that we're going to focus on this for this is 471, 472, and then 474. We're not worried about 473. It's a vocabulary little page. I mean, you can do it obviously if you want. It's not going to hurt you, obviously. It is not necessary, though. I mean, it's all about fraction models, and we've done tons of fraction models. So I believe it's fraction models. Yep, fraction models, and we've done a ton of those, as I said. So the big thing about this unit here, or this lesson here, is going to be focused on dividing unit fractions in world problems. So it's going to be all focused on just problem solving and continuing to practice dividing. Last lesson was all about teaching us the concepts and how to do it. Now we're transitioning into actually just doing it, okay? So I want to go review a couple concepts here real fast. The idea that we have 6 divided by 1/3, okay, right? Okay, and so when we see 6 divided by 1/3, the idea is that we have a total of 6 wholes, right? Just reviewing here. Oh, this actually is similar to the problem we're going to do here in a second. But I just wanted to review something real fast here. Okay, if we have 6 divided into thirds, okay, it's important to think about that we're not dividing these into thirds, right? We're dividing each one into thirds, right? That's kind of the concept here. Into thirds, right? Okay. And so this has given us the total number of 1/3 groups. So when we're looking at the problem this way, we can think about this as 6 times 3, right? So what we're looking at is dividing by 1/3 is equal to multiplying by 3 in these situations, right? So we can think about multiplication through this lens. If we see, because it's a unit fraction, because it is a unit fraction, we can look at it as 1/3. Dividing by 1/3 is the same as multiplying by 3. So therefore, with that in mind, obviously the inverse is true as well. Multiplying by 3, oh, sorry, dividing by 3, right, is going to be the same as multiplying by 1/3, right? The inverse is going to be the same as well. You guys might remember at the beginning of the, not the beginning of the year, but in the middle of the year, that when we started talking about powers of 10, we talked about multiplying by 10, right, was the same as dividing by 1/10. We also said that dividing by 10 was the same as multiplying by 1/10, or multiplying by 1/10, right? Well, as a fraction or decimal, doesn't matter. Okay, so if these are true, we all understand, we all should have accepted this as a truth at this point from all the evidence that we've shown, then this is going to work as well. So if I have a problem where I'm doing 6 divided by 1/3, why not just multiply by 3? And it works for these unit fractions like that, okay? So the idea is that we can just use the reciprocal of 1/3. Reciprocal 1/3, the reciprocal kind of means the opposite, kind of the inverse of it. So 1/3, okay, compared to 3, which would be 3/1, correct? So instead of dividing by 1/3, we can just multiply by 3/1. And that'll make our lives really easy. We need to be able to model it because it shows understanding. Just multiplying or dividing wherever and just getting an answer, but not knowing how that worked or what it looked like is a problem. Now let's say we have this problem, and let's say we have 1/3 divided by 6, let's say, okay? When I look at this problem, it's going to be important that I understand that my model needs to show what I have. This model showed what I had, which was 6 wholes, right? This model here needs to show what I have, and what I have is 1/3, because that is the amount that is being divided up. So I have 1/3, right? Okay, that's what I have. These other blank third parts over here are important because they help me see the value of each tile or each part. So the idea is that this is going to be divided into 6 parts. 1, 2, 3, 4, 5 lines to make 6 there. And that is, this gives me out my total number of parts, correct? And so then I have 1, 2, 3, 4, 5, 6 this way, and 1, 2, 3 this way. So 6 times 3 gives me the total number of lengths and widths there. It's going to give me 18, so I'm dealing with 18th. Each part is going to be 18th, so this is 1/6. This one right here is 1/3 by 1/6, and that gives me the value of 1 part, right? So when I'm looking at this problem here, 1/3 divided by 6, the idea is if I have a third of a cup of gummy bears, 6 friends are sharing it, how many cups of gummy bears does each friend get? Each friend would get 1/8 cup of 1/18th cup of gummy bears, okay? So I wanted to review those concepts before we jump in today. Now I use these area models. There's other models we can use. So I'm going to use a different model when we get into problem solving on this one here today, okay? All right. The whole point of that, guys, was that we can multiply to divide. We did it back with whole numbers. We use it all the time when we divide, right? We multiply to divide and make our lives easier. Okay, here's our problem of the day. Okay, it says Micah is running a 6-mile race. There's water stops every half mile and at the 6-mile finish line. Okay, so that's important. Okay, at every half mile, there's it. Okay, and then at the finish line, it's there too, right? How many water stops are there in all? Use a visual model to show your solution. Okay, this is where you should stop, pause the video, try to do this yourself. Give yourself space. So if down here in your try section, try to do it in the top half of it. Give yourself space in case you make a mistake. You can always add my strategy, okay, to the bottom part of it. But there should be a visual model here. That's what I'm expecting to see, a visual model when I look at these. Okay, so let me pull this out a little bit here. Okay, so again, if you haven't paused and done this on your own yet, you should do that. Okay, let's go and do this together then. Check your work here with mine. So we have a 6-mile race. So let's go, that's what we have. That's the total amount that we have, right? Okay, and there's water stops every half a mile. Okay, so let's just go ahead. Let's not think about it from a mathematical standpoint. Let's just think about it from a practicality standpoint, right? Okay, so if I go ahead and I draw this race from, this is the start, this is the finish, right? And this is 0 miles, and this is 6 miles. Okay, now I'm going to roughly put in my mile markers because it's 6 miles, so I'm going to put mile markers in because we're looking at every half a mile. So let's just say roughly, let's just go here. That's 1 mile mark, let's say. That's the 2 mile. That's 3, it's about halfway. 4, 5, and then 6, the finish line. Remember, it's important. It does say that there's going to be one at the finish line as well. So we'll think about that as well. Yep. So this is our essentially the race track, right? And we've broken down by the mile. But there's water every half of a mile. So I'm going to just grab a different color so you guys can see it. And I'm going to put a W for water at each stop. Okay, so at the half a mile point, so this is the half mile point, there's going to be water here, right? Okay, that's the half mile point, right? I should have done this the opposite way. I should have put the, no, I'll do, from now on, I'll do that the other way. Yeah. So this half mile, there's water, right? But this is also at a half mile point. So it's important. A lot of students will be like, well, that's 1. That's not a half. Well, isn't 2 halves make 1? So that would be another half, wouldn't it? Okay. So this would be the same as 2 halves. Therefore, it is a half, right? Because it's the equivalent. So we're going to put the W up here. I should have, remember, I should have inversed that. Okay. So then we're going to go to this one. This is 1.5, right? This is 1, this is a half, right? Oops, I already did that. And we're going to put water here. This would be 3 halves. No, sorry, 4 halves. Oops. We have water here, and so on and so forth. So I'm going to have water here, another halfway point, water here, another halfway point, water here, another halfway point, water here. And then at the 6-mile finish line, there's also going to be water. Okay. So the idea is that everywhere that I have a W, I have a water station. Okay. So how many water stations are there? Well, we can just count them up, can't we? Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 water stations. Now, what did we do when we drew this, though? Okay, mathematically, what did we actually do? So we logically just solved the problem, right? We planned it out, we solved it, we were able to break it down and do all that, right? But what we did here is we took the 6 miles and we divided it into into one half mile segments, right? Okay, so the problem is 6 divided by 1/2 is going to give us the number of water stations, all right? Now, naturally, if we go ahead and just look at one hole here, okay, how many half parts are in a hole? Well, there's 2, correct? There's 2 half parts. There's 1/2 here, 2 halves here. I'm mark this as 2 halves, okay? So the idea is that 1 mile has 2 parts. So therefore, for each mile, there are 2 parts. Therefore, and there are 6 miles, and for each mile, there are 2 parts. Therefore, because there are 2 parts, there are 2 water stations. So we can multiply by 2 in order to solve this, okay? So when I divide by 1/2, I'm doubling the original number. So it's the same as multiplying by 2, because there's twice as many, okay? You guys with me here? Okay. So therefore, 6 divided by 1/2 is going to be 12, and 6 times 2 is 12. And so naturally, when I see this relationship, it doesn't really matter what the fraction is. If it's a unit fraction, I can just multiply it by, I can multiply my whole number by the denominator essentially, right? Makes life a lot easier. But that works when it's a unit fraction, right? Okay. So, yeah, hopefully that makes sense. We've been doing this for a little while now. Now, there are obviously other models we could draw. If you used bars, that's fine. Um, uh, there's a lot of different ways you can do this, okay? I like this way because it actually tells the story of what's happening here, right? There's a start, there's a finish, there's a progress. There's, you can almost see that, hey, they're running down, a street here, and every half a mile on this street, there is this water location. Okay, let's go ahead and move on to the next page here. All right, let me focus this, make sure it's good and focused here. Okay. All right, how many water stops are there in all? Explain how you could use a number line to support your answer. Well, we did just use a number line, didn't we? Basically, okay. So just go ahead and write how many there are, but then kind of basically just go through and explain how we use the number line and why it was effective. Okay, your understanding of using. Remember, you might be like, well, Mr. Marks, what are you talking about? What did you write down? Because you putting something on the paper is helping you put it up here more permanently, right? Okay, and also it proves whether you actually understand what you're talking about or not, whether you can put it in your own words. Don't just copy on. That's why I'm not going to write anything. I want you to write it in your own words. I don't want you just to copy something I write. I want you to write it in your own words, okay? There's power in that, okay? Let's go ahead and look at number 2 though, okay? It says, on the previous page, you used a visual model to solve word problems involving dividing a whole number into unit fractions. You can also use equations as to represent and solve these types of problems. Consider these word problems, okay? Mike runs a 5-mile race. There are water stops every 1/3 of a mile, and at the 5-mile finish line of the new race. How many water stops are there in all? So we already know how to solve this problem. We already did 6 divided by 1/2, and we already did the equations for that on the previous page, right? So for this, it's going to be pretty much the same thing, isn't it? Okay, so what we're going to do here is we have how many? It's a 5-mile race, so it's going to be the miles of the race is 5. We're going to divide this by the number of stops, the fractions of the miles for each stop, which is 1/3, right? It's 1/3. And as I mentioned on the last page, we want to think about using multiplication here, okay? So we know that there are 5 miles and the number of water stops in each mile, well, because we're in thirds, that each mile is broken into 3 sections. Therefore, there are 3 water stops in each mile segment, right? Yep. So how many water stops are in this race? Okay, well, naturally, 5 times 3 is 15, right? There are 15 stops. Okay, now explain how you know this. Well, hopefully based on what we did up here, the discussion we've had, you can quickly explain that. It shouldn't be too complicated. The idea, especially the idea that for each mile, there are 3 stops. Therefore, for 5 miles, there are 3 stops per mile. So 5 times 3 is 15. Seems like an adequate explanation to me. Okay. All right. So like I said, this page here, not worried about you doing. Okay, so don't, even number 2, I'm not even worried about number 2. It's a pretty basic stuff. Okay, then for you, on your own, okay, on your own, you have one problem today. So if you watch the video, then we did the hard work. You have one problem today. I know there's 2 problems today. This is check your answer. So when you check your answer, the idea is use another strategy, right? If you if you use your visual model up here and you drew the model and you counted out, use multiplication down here, right? Easy peasy. If you multiplied, if you show your division equation up here, show multiplication equation down here to show it, to solve it. Okay, so I think we're good to go. You've got this. If you have questions, I will be online later today to help. But I think today's assignment is pretty easy. A nice way to end your Friday. Pretty straightforward, especially if you watch the video, guys. Hey, next week we have 1 week left. We have next week, last week. Okay. If you're behind, you got to catch up. Of course, if you're watching this, that means you're probably on time, right? So good job for those of you that are watching this video and on time. Proud of you. I miss you guys a ton. We're going to be posting some stuff about one final 5th grade social. It's not going to be more of a social, kind of a little bit of a farewell, ceremony kind of thing. And we're putting that in, planning that out right now. So we're going to do that at the end of next week. So look forward to that. I will talk to you later. Have a wonderful weekend. Bye-bye.